Hi, Assalamualaikum and very good morning. In this video, we are going to learn how to apply differentiation in maximum minimum problem. Okay, previously we have learned that when we have turning point or stationary point, dy dx equals to 0. Okay, let's say we have, here we have smile curve. Okay, smile curve. So here we have y. Okay, y is fx. Okay, when y minimum. Okay, so therefore dy dx equals to 0. Okay, gradient is 0. Okay, so now same thing when we have, let's say, set curve. Okay, here we have y. Same y equals to fx and y maximum. Okay, dy dx equals to 0. Okay, so actually we can apply all these things in daily life problem. Okay, for example, let's say here we have area. Area is A. A is a function in terms of x. Okay, so if we have maximum or minimum area, meaning A, so therefore dA dx equals to 0. That we differentiate, we equate to 0. Okay, same thing if we have, let's say, volume. Okay, volume V. V, let's say, function H in terms of X. So, maximum or minimum volume, meaning that dV dx equals to 0. Okay, now let's do examples, problems involving maximum or minimum values. Okay, here example number 1. A piece of wire of length 60 centimeter is used to form a rectangle. Find the values of length of width for which the area is maximum. Okay, here we have clue, which is rectangle, and area is maximum. Okay, just now we agree when maximum or minimum we differentiate equals to 0. Okay, here we have rectangle. So therefore we draw rectangle. Okay, we have rectangle with the length and width. Okay, let's say length is x and width is y. Okay, so a piece of wire of length 60 centimeter is used to form. Okay, form rectangle, meaning that 60 centimeter is the perimeter. Okay, perimeter. Okay, but to find perimeter is we have 2x plus we have 2y. 2y equals to 60. Okay, so when we simplify, we get x plus y equals to 30. Okay, so enough. So then the next sentence, find the values of length and width for which the area is maximum. Okay, so now we have another one is area. Okay, we already knew that to find area is length times width. Okay, which is x times y. Okay, here we have two equations involving perimeter and area, and we have two unknowns. Okay, so we know that if we have two unknowns, to solve this one, we can use simultaneous equation. Okay, so to use simultaneous equation, for the first equation, we can choose any unknown as subject. Let's say I choose y. Y equals to 30 minus x. Okay, you can choose x as subject as well. Okay, so here we have equation 1 and this one equation 2. Okay, so 1 into 2. Okay, here we have area, let's say A. Okay, xy. So xy is 30 minus x. Okay, we simplify, we expand, we get 30x minus x squared. Okay, okay, just now we agree that maximum minimum we differentiate, we equate to 0. Okay, so now we have A in terms of x, we differentiate, we get dAd x equals to this one, 30 minus 2x equals to 0. So therefore x equals to 15. Okay, when x equals to 15, you can substitute into equation of area. Okay, just now area is this one. Okay, so we substitute into area. So A maximum equals to 30 times 15 minus 15 squared. Okay, so here we have 2 to 5. Okay, actually we can prove. Okay, we can prove this one is maximum. Okay, we differentiate another time. Okay, so this one we have dA dx. We want to prove. Okay, so d squared a dx squared is negative 2. Okay, so negative 2 is less than 0. Okay, less than 0 we have set curve, so therefore this one is maximum. So this one is maximum area. Okay, number 2, a cylinder, okay, that open, okay, at the top has a volume pi meter cube. The radius of the cylinder is x meter and the height is h meter. Show that the surface area of the cylinder is A equals to pi x squared plus 2 pi over x. Okay, so we draw the cylinder with open at the top. Okay, so cylinder. Okay, this is cylinder. Okay, radius is x and height is h. Okay, we have volume. Okay, clue is volume pi. Clue is volume pi. Okay, so volume equals to pi. Okay, but we know that the volume of cylinder is pi r squared h. Okay, so equals to pi, then we can simplify, become r squared h equals to 1. Okay, so we already have one equation here, and we are going to show that the surface area. Okay, surface area. Okay, surface area. Okay, don't forget that we have open cylinder. Okay, for surface area of open cylinder, for the bottom one, the area is pi r squared. Okay, for the curved surface area is 2 pi rh. Okay, meaning that the area is, let's say A equals to pi r squared plus 2 pi rh. Okay, so now we have equation of volume and area, and we have two unknowns which are r and h. So meaning that we have to use simultaneous, right? Okay, so let's say we substitute h as subject. So here we have h equals to 1 over r squared. Okay, so this one equation 1, this one equation 2. So 1 into 2. Okay, so therefore area is pi r squared plus 2 pi r. H is 1 over r squared. Okay, so therefore this one become pi r squared plus 2 pi over r. Okay, but given the radius is x. Okay, so here we have pi x squared plus 2 pi over r. Okay, so here previously the question asked you to show the surface area is x, pi x squared plus 2 pi, sorry, this one x, this one x. Okay, so see here, this one. Okay, same, right? So shown. Okay, shown. Next sub question, we have to find the value of h when a is minimum. A is minimum. Okay, minimum, differentiate and equate to 0. Now we have a in terms of x, so we differentiate, we equate to 0. Okay, so for b, we differentiate equal to 0. Okay, so b we have a equals to pi x squared plus 2 pi over x. So you have to move up x. So here we have 2 pi x power of negative 1. So differentiate dA dx equals to 2 pi x, minus 2 pi x to the power of negative 2. Okay, so equals to 0 because minimum. Okay, we simplify, we get 2 pi x minus 2 pi over x squared is 0. 2 pi x equals to 2 pi over x squared. X cubed equals to 1, so x is 1. Okay, so the question asks you to find the value of h. Okay, the value of h. Okay, just now we have this relation. Okay, h equals to 1 over r squared. Okay, so h equals to, here we have h equals to 1 over r squared, and r actually is x, so h equals to 1 over x squared. We substitute into the equation, so 1 over 1 squared equals to 1. Okay. Okay, so now question number 3. The diagram shows a cuboid given that the total of all sides, okay, is 40 centimeter. Okay, total all side. Okay, 40 centimeter. Okay, show that the volume, okay, the volume of the cuboid is V equals to 40x squared minus 20x cubed. Okay, so here we can see we have two relation, we have two things have to create. The first one involve total all sides, and the second one involve volume. Okay, so now A. Okay, total all side. Okay, since of this is cuboid, so you have to total all side. Here we have, let's say, h. 1, 2, 3, 4. We have 4h. Okay, plus x. 1, 2, 3, 4. Okay, 4x. Okay, as well. Okay, we have 4 side of 4x. 1, 2, 3, 4. Okay, so 4 times 4x equals to 40. Okay, so then we simplify, become 4h plus 4x plus 16x equals to 40. This one is 4h plus 20x equals to 40. Simplify, h plus 5x equals to 10. Okay, so then this one straight away you can make a h as subject. 10 minus 5x. Okay, 1. Okay, here we have volume. Volume of cuboid. Okay, volume is length, height, width. Okay, we have for x, and h. So 4x times x times h. Okay, so then we simplify, we get 4x squared. H is 10 minus 5x. Oh, sorry, this one too. Okay, wait. This one too, equation 2. Okay, so 1 into 2. Okay, so V equals to 4x squared. H is 10 minus 5x. So we get 40x squared minus 20x. Okay, so shown. Okay, so shown. X cubed. So shown. Okay, so then B. Okay, for question B, find the values of x and h for which the volume is maximum. Okay, volume maximum. Differentiate equal to 0. Okay, so differentiate. So we have V in terms of x. We differentiate, we get dV dx equals to 80x. minus 60x squared equals to 0. Here we have 20x 4 minus 3x, okay, equals to 0. Okay, here we have x equals to 0 and x equals to 4 over 3. Okay, so find the values of x and h. Okay, now we already have x. So to get h, okay, h is 10 minus 5 times 4 over 3. Okay, so this one 10 minus 20 over 3. So we have 10 over 30 minus 20, 10 over 3. H is 10 over 3. Okay, so C. Okay, for question C, find the maximum volume. Okay, so then we have volume here. Okay, here we have volume. Okay, and we have x is 4 over 3. Then we substitute x equals to 4 over 3 into volume. Then we get V maximum. Okay, so V maximum equals to 40 times 4 over 3. Okay, 4 over 3 squared minus 20 4 over 3 cube. Okay, so this one we get the final answer is 23 19 over 27. Okay, so actually we can test. This one is maximum. Okay, just now your dvdx is this one. Okay, dvdx, this one is dvdx. Okay, then we differentiate another time. Okay, so dvdx is just now. Okay, dvdx is 80x minus 60 x squared. Okay, so d squared v dx squared equals to 80 minus 120x. Then we substitute x equals to 4 over 3 d squared v dx squared equals to 80 minus 120 times 4 over 3. Okay, so this one become 3 times 1, 3 times 40. So 80 minus 160, so negative 80. Okay, so negative 80 is less than 0. So maximum set, so maximum. So proven lah. Okay.